Let's talk about quality of service for wireless. Remember that in the wireless controller, you can manage quality of service profiles such as platinum, gold, silver, and bronze. But these profiles are only meaningful for the wired part of the network. That means that for the path between the access point and the wireless controller. Also, we have the issue that all the standards such as .11a, B, and G are heavily based on the distributed coordination function in order to work. The DCF establishes that devices must calculate a random time that is known as the backoff time before trying to transmit over the air. This time is the same for all devices and streams, so there is not really a way to differentiate anything over the air with these all the standards. There is no way to give more priority to voice, for instance. The .11e standard that offers the Enhanced Distributed Channel Access, or EDCA, provides a way to do actual quality of service over the air. And the standards .11n and .11ac support the ADCA. With EDCA, there is actually a new field within the .11 header that is known as the user priority field that offers 8 possible values and 4 categories. The predefined categories for quality of service over the air are voice, video, best effort, and background. So this standard will provide actual backoff timers that are different per category. So notice that the voice will have a shorter interframe space and shorter contention windows, whereas the background category will have larger interframe spaces and larger contention windows. Other features such as transmission opportunity and T-spec are defined in this standard. Now with the release of .11ax or Wi-Fi 6, new ways to see quality of service are being explored, such as taking advantage of the modulation itself and taking advantage that with this new standard, uplink MIMO is available. So if you want your quality of service mappings to persist from the wired world into the wireless network, you have to notice this requirement. If packets come from the wired world into your wireless controller, if you want quality of service to work, you might want to have your DSCP values that comes from these packets getting mapped into the cap, WAP, tunnel headers. So the wireless controller can do that, and when these packets arrive through the cap WAP tunnel into the access point will have to map the DSCP values that are found in the cap WAP header into user priority values over the air. So in that way, you are guaranteeing having quality of service from end to end. The opposite is also required when packets arrive over the air to the AP. The access point has two options: to either map the user priority value into the DSCP of the header of the cap WAP tunnel, or it can choose to use the DSCP value that comes within the packets that are arriving through the air. You can choose which one to select in the wireless controller. Selecting one of these two options, you either trust the DSCP value of your packets over the air, or you trust the user priority values that you're receiving over the air. In order for this mapping to work, you will have to use Platinum QoS profiles. Always use Platinum. There is some product that is known as the Application Visibility and Control, or AVZ, that is based on Netconf and Yang. It is the equivalent of NVAR2 for wireless, so it means that it can let you discover which applications are running on your corporate and guest WLANs. And it packages more than 1,400 signatures, so it can recognize more than 1,400 applications such as DirecTV, ESPN streaming, FaceTime, Cisco IP camera, etc. Now, with the new generation of wireless controllers, which are the 1900 Catalyst, you can actually create quality of service policies just the way that you do it in a router. You can create policies that have classes, where these classes match certain traffic, and through the policy you can define bandwidth for each class, and you can also do marking. And with this new generation of wireless controller, you can customize your applications within AVC.